Hello, class. We're about to start lesson 2-3, 88 miles per hour. And our page number is page 157. Our learning objectives is to interpret a rate of change, to predict a future value from a rate of change, to calculate a rate of change, to find the intercepts of a line, and interpret the meaning of the intercepts of a line. Okay, now it says the future is something which everyone reaches at the rate of 60 minutes an hour, whatever he does, whoever he is. Anyone familiar with the classic movie Back to the Future instantly recognizes the significance of 88 miles per hour. It's the speed the DeLorean time machine needed to reach in order to travel through time. Speeds like 88 miles per hour are familiar examples of the topic of this lesson, rates of change. Our world is a dynamic, ever changing place, so studying the rate at which things change is an excellent way to study the world around us. The amount your grade changes as you spend more time studying. That's a rate. Your hourly wage if you work a part time job, rate. A waitress's decrease in tips as fewer customers eat at a restaurant, rate. They're everywhere. Fortunately, studying rates will tie together some of the skills we've already practiced in this course, meaning we're in good position to make the most of this useful topic. Now it says here, a rate is a ratio that compares two quantities. By rate of change, we mean rate that compares the change in one quantity to the change in another. A speed like 88 miles per hour qualifies because we could write it this way, 88 miles over 1 hour. This quite literally compares a change in distance, 88 miles, to a change in time, 1 hour. That's exactly why we measure speeds in miles per hour. The word equivalent is an important word in math and one that we'll use often in this course. Make sure you clearly understand what that word means. For our purposes, we'll say that two quantities are equivalent if they have the same value or are interchangeable, even if they look different. It says here, if you make $100 a day for doing a certain job, how much money would you make in a 5 day work week? Okay, so we make $100 a day and we have a 5 day work week. So 100 times 5, you'll make $500. Number two, are $100 a day and $500 over 5 days equivalent rates? What does this mean? Yes, they both describe $100 a day. They both describe $100 per day. Also, the fraction $500 over 5 days simplifies to $100 for every 1 day, which is what we have here for number two. Now, we move on over to page 158. It says question two demonstrates a useful fact about rates of change. They can be scaled up or scaled down to fit a given situation. Scaling up a fraction is done by writing an equivalent fraction, that is, one that has the same value, using larger numbers. Scaling down is writing an equivalent fraction with smaller numbers. These processes are done by either multiplying both the numerator and denominator by the same number or dividing both the numerator and denominator by the same number. So for number three, it says write a fraction equivalent to 60 miles over 4 hours that has 2 in the denominator. So we have 60 miles over 4 hours. They want us the denominator to be 2. So we ask ourselves, 4 divided by what is 2? And we know that it's 2. So we'll divide the numerator and denominator by the same value. So this would be 30 miles over 2 hours. Now, number four, or let me just say this, or you could write it like this as well. Either way is fine. Okay, number four, it says write a fraction equivalent to 60 miles over 4 hours that has one in the denominator. Okay, so 60 miles over 4 hours. To get one in our denominator, we divide both by 4, and that will give us 15 miles for 1 hour, or we could write 15 miles per hour here. Well, actually, we still should write the 1. So it's per 1 hour. It says write a fraction equivalent to $320 over 4 days that has 10 in the denominator. It says first scale down, then up. So we'll take the $320 and divide it by 4 days. Now we can use our Desmos calculator. Let me move this here. We could take 320 divided by 4, and that gives us $80 over 1 day. Now we want to scale, we want to get 10 in our denominator. So we will multiply the numerator and denominator by 10. So it'd be $800 over 10 days. Say number 6. If one bicyclist is pedaling at a rate of 40 miles in 3 hours and another at a rate of 50 miles in 4 hours, which is faster? So we have 40 miles in 3 hours and 50 miles in 4 hours. We have to find out which one has the larger value. So we could do it like this. We could take 40 divided by 3, and then we could take 50 divided by 4. And you notice here that 40 divided by 3 is equivalent to 13.3 miles per hour, miles per 1 hour. And then here, this would be 12.5, and I should have put the repeating 3, 12.5 miles per 1 hour. So we know that the first value, this is the largest. This value is the largest, or the fastest, I should say. Yeah, I should put down this is the fastest. Okay, now we go here to problem number 7. It says most experienced runners get to a point where they can comfortably jog long distances at a consistent pace. This pace, of course, is another way to say rate of change, because speed is the rate at which distance changes compared to time. One particular runner jogs one lap around a 400-meter track in 2 minutes. In questions 7 through 16, you can assume that the runner can maintain this pace for a long time. So it says here, for every blank minutes, the runner jogs blank meters. So it says here, for every 2 minutes, the runner jogs 400 meters. Now it says complete the table, continue the pattern for times, and find the associated distances for this runner. So if 2 is 400, 4 is 800, and then 6 would be 1200, then 8 would be 1600, then 10 would be 2000, and then 12 would be 2400. Because if you notice, the time goes up by 2 minutes and the distance goes up by 400 meters. All right, now we move on to the next page. Number 9, it says, notice that the rate at which the runner's distance changes is constant. When the rate of change is constant, a quantity illustrates what type of growth. It would be linear. It says write the runner's rate as a fraction using meters in the numerator. So remember, it's 400 meters for every 2 minutes. And that was done in problem number 8. For every 2 minutes, 400 meters, and they wanted meters in the numerator. So this is the runner's rate here. It says 11, write this rate as a unit rate in meters per minute. So remember, with the unit rate, the difference between a rate and a unit rate is that a unit rate must have 1 in the denominator. So we could divide both of these by 2, and we add 200 meters over 1 minute. So this could be written as 200 meters per minute. And you don't have to write the 1 for the minute. Okay, number 12. It says convert your rate from question 11 to meters per second using dimensional analysis. So we already have meters per minute, but we want to change this to meters per second. So we will have to change these minutes to seconds. So we have 1 minute over 60 seconds. The minutes will simplify out, and we add 200 meters over 60 seconds. So if we put this in our Desmos calculator, that would give us approximately 3.33 meters per second. Now 13, it says what distance will the runner cover in 40 minutes? So since we already know it's 200 meters per 1 minute, all we would have to do is multiply this by 40 minutes. The minutes will simplify out. 200 times 40 is 8,000. So it'd be 8,000 meters. Now, number 14, it says what distance will he cover in 40 seconds? So we would take here what we had for the seconds, 3.33 meters per second. So we will have our 40 seconds over 1. The seconds will simplify out, and this would give us 133.2 meters. Now 15, based on the previous 2 questions, can you write a formula for finding the distance traveled by an object when you know the speed and amount of time traveling at that speed? So what we would have here, we would have our distance is equal to our speed times time. So the distance, this is our distance, is equal to the speed times time. All right, now we move over here to the next page. And at the top, problem 16, it says, what would this runner's total time be for a 10K race? 10 kilometers, that is. Recall that 1 kilometer is equal to 1,000 meters. Your answer to question 11 will help. So if we go back to question 11, it's 400 meters for 2 minutes. So we could do 11, or we could do problem 13 where we had 200 meters for 1 minute. So I probably would go with that. So we want to go 10 kilometers, and we want to see how long it would take us to do 10 kilometers. So remember, it's 1,000 meters for 1 kilometer. And then it's 1 minute for every 200 meters. So the kilometers will go, and then the meters will go. That is why we put minutes in our numerator and meters in our denominator, so those units will simplify out. So then here, we add 10,000 over 200 minutes. So when you divide this out, it will leave you 50 minutes. It says, while we develop the formula in questions 13 through 15, it's not a formula you should worry about memorizing because one, this is not a physics course, and two, you can use dimensional analysis to do calculation with rates, which is better than memorizing a bunch of formulas. So let's look at another example. Now here we have the solved example, which I always tell you to read that at your leisure. It gives you basically the dimensional analysis, basically what we did in problem 16. Okay, now it says, at this point, we know that a rate of change measures how many, how some quantity is changing. Now ponder this question. Do rates of change change? That might look like a typo, but it's not. The rate at which some quantity changes either stays constant or changes. For example, if you make $9 per hour at a job, the rate at which your pay changes as you work more hours is always the same. Your pay grows at the rate of $9 per hour. But if you're driving in traffic, the rate of change of your position, which we commonly call speed, probably changes quite a bit. Our next order of business is to study situations where the rate of change, a quantity, the rate of change of a quantity stays constant. In that case, modeling that situation with an equation or a graph is very manageable. All right, so we go here to page 161, and then we start here at problem number 1. According to taxifarefinder.com, a cab ride from the airport in Las Vegas will cost you an initial charge of $5.10 plus $2.60 per mile. Use this information to fill in the rest of the table describing the total cost for various distances. Then create a scatter diagram using the distance as x coordinate and the cost as y coordinate. Okay, now, so for 0 miles, you would charge $5.10. For 1 mile, you would charge $7.70. For 2 miles, you would charge $10.30. Now, this is what we could do. Let's see the difference in cost here. 770 minus 510 is $2.60. So 1030 minus 77 is another $2.60. So it's going up $2.60. So this would be $12.90. This would be $15.50. And then finally, this would be $18.10. Okay, now we will plot these points. We have 0 and 510, which would be a little bit above half. Then we will have 1 and 770, should be about here. Then we will have 2 and 1030, should be about here. 3 and 1290, should be a little bit from the center. And then 4 and 1550. And then 5 and 1810. Now, of course, I don't have a straight edge right now, so I'm going to connect these points as best I can. It should form a straight line. Mine is a little off, but you get the picture here. And you must put an arrow here to indicate that it goes on forever. Now it says, what do you notice about the pattern that the points on your scatter diagram are making? Use observation about a pattern to connect the points, drawing a graph that represents the cost of a cab ride. Now, again, if you travel more than 5 miles, this is what the arrowhead is telling you here. And then it says, what do you notice about the pattern that each point forms a line and their value goes up by $2.60 for every mile. All right. Now we go down here to number 3. It says the point where any graph crosses the y-axis is called the y-intercept for the graph, and a point where the graph crosses the x-intercept is called an x-axis is called an x-intercept. Write the coordinates of the y-intercept for the graph that you drew. More importantly, what information does the y-intercept represent? Does the graph have an x-intercept, y or y not? Okay, now it says, first of all, the y-intercept. The y-intercept is, we'll put parenthesis, 0, $5.10. And then this means that when you get in the cab, you owe $5.10. Now, the next thing, as far as the x-intercept, there is no x-intercept because that would mean the cab ride costs nothing. That's why you don't have an x-intercept. Okay, next. How much more will you pay for a 3-mile ride than a 2-mile ride? So we would go here, 3-mile ride was $12.90. 2-mile ride was $10.30. And we already figured that out earlier. It was $2.60. Okay, how much more will you pay for a 5-mile ride than a 2-mile ride? 5-mile ride is $18.10. 2-mile ride is $10.30. So that would be $7.80. Okay, it says explain why that makes sense based on your answer to question 4. And it makes sense because there is a 3-mile difference in this problem. And 1 mile has a difference of $2.60. So 3 miles. So a 3-mile difference would be $2.60 times 3, which is $7.80. Okay, now go here to the back. It says pick any 2 points on the graph that you drew and subtract the second coordinates, then divide the result by the difference of the first coordinates. Each person in your group should pick a different pair of points. What does the result represent about the cab ride? Okay, so basically, we're just doing slope here. So I'll just pick 2 points. I'm going to write them up here. I'm going to pick the y-intercept, which was 0, 5, 10. And then I'm going to pick the 2-mile, which is $10.30. So we had $10.30 minus $5.10, all over 2 minus 0. 1030 minus 510 is $5.20 divided by 2 is to give us $2.60. All right. And this is the cost per mile. And dividing the difference of the two costs by the difference of the two distances in question 6, you found the rate of change of the cost as distance changes. When applied to the graph of a line, we call the number which describes how steep the line is the slope, which we already covered before, so we really don't need to go over this tan box. But if you need a refresher, you can read that at your leisure. Okay, number 7. If you were to connect the points 1, 7, 70 and 5, 18, 10 on the graph in question 1 with a triangle, it would look something like this. Label the coordinates of the two given points on the triangle. Okay, so the two given points, this right here would be your 1, 7, 70. And this right here would be your 5, 18, 10. All right. It says how much more distance was added to the ride going from 1,770 to 5,1810. And it says label this value on the triangle. So if you think about it, from here to here, this would be 4 miles. Because remember, this is the x value. So the difference in the x values would be 4 miles. And 1810, well, first of all, since it's 4 miles, then what we would have to write is the value at 4 miles. So 4 miles would be $10.40. All right. Now, or we could have just, well, no, subtracting wouldn't have worked. But at 4 miles, it would be $10.40. Okay, now we move on. Well, actually, yes, we could have subtracted 1810 minus 770 would give us $10.40. So yes, we could have subtracted the x values and the y values to give us our points here. Okay, now we move on to problem number 9. It says how much cost was added to the ride going from 1,770 to 5,1810. Label this value on a triangle. So basically, when I did problem number 7, when I labeled both of these, that took care of 8 and 9. Because the 4 miles took care of 8 and the 1040 actually took care of number 9. Now, number 10, find the slope of the line using your answers to question 8 and 9. Okay, so the questions 8 and 9. All right, so what we would do, we would take the 1040 that we have for the y value, and then the 4 miles that we have for the x value. When we divide these two, it'll give us $2.60 per mile. It says, what do you notice? The slope is the same as it was in problems 4 and 6. Okay, number 11. How much would 4 miles add to the cost of the taxi ride? Would it matter if the change was 1 mile to 5 miles or if it was 20 miles to 24 miles? It would add $10.40. And it doesn't matter which 4 miles it is. because slope is constant. Number 12, the thing that makes a line is the fact that the slope never changes. We now know that the slope of a line describes the rate at which the y coordinate changes compared to the x coordinate. Based on this, how can you decide if the relationship between two quantities might be modeled well by a straight line? Okay. Um, Slope is determined by 2 points on a straight line. I should say by at least 2 points. So I'll put at least. So it's by at least 2 points on a straight line. So the 2 points would be modeled well on a straight line. $13, it says estimate the distance of a $16 cab ride. You can use either the table or the graph, but make sure you explain how you got your answer. Okay, a $16 car ride. Okay, we can explain how we got our answer by actually doing the equation. Now remember, y equals mx plus b. Now we have our slope. Our slope was $2.60. And our b, our y-intercept, was $5.10. Now we really don't have to write out the dollar signs, but I just did that here just to show you the units we're working in. So now they ask us here to find out how many miles traveled to get the $16. So we will replace y with $16 and we add $2.60x plus $5.10. Subtract $5.10 on both sides. So this would be $10.90 equals 2.60x. Divide each side by 2.60. So, all right, so let me put this in here. We have 1090 divided by 2.6. So that'll be approximately 4 miles. So x, if we round it to miles, because we're estimating the distance, it'll be approximately 4 miles. Okay, everyone knows that after you buy a car, in most cases, its value decreases as it gets older. Suppose you bought a used car for $15,000 a few years ago, and its value has been decreasing at the rate of $2,000 per year since then. Make sure you answer each of the remaining questions with the full sentence, with punctuation and everything. Okay. So now we come here to the back. It says find the y-intercept of the graph and explain what it means. Now remember, the y-intercept is when x is 0. This is considered x, this is considered y. So when x is 0, y is 15,000. So your y-intercept is 0, 15,000. And explain what it means when the car is new, it cost $15,000. It says find the slope of the line and explain what it means. Now, to find the slope, we could take this y-intercept and we could actually do we could take the y-intercept at one other point. So let's take the 1, 13,000. So we have 0, 15,000, and the 1, 13,000. And we could do the slope formula. So it'd be 13,000 minus 15,000 divided by 1 minus 0. So it'd be negative 2,000 over 1, which is negative 2,000. And it says, what does it mean in this situation? Each year, the car's value goes down by $2,000. Now, 16, it says estimate the value of the car after 42 months. Now, first of all, if we look back here at our table, this is in years. So we first need to convert those months to years. So 42 months, and we could use some dimensional analysis. It takes 12 months to equal 1 year. The months will simplify out, and we will have 42 all over 12. Now, when we simplify this out, 42 divided by 12, it'll give us 3.5 years. All right, so it'd be 3.5 years. So they asked us the value of the car after 42 months. So we could take y is equal to, now the slope is a negative 2,000 times the amount of years plus the 15,000. Now when we put all this in our calculator, it will give us $8,000. So we could put after 42 months, the car is worth $8,000. Okay, 17. Estimate the number of years it took for the car to reach a value of $6,000. So we have y equals negative 2,000x plus 15,000. And we'll put $6,000 in for y. And then we will solve for x. So we'll subtract 15,000 on both sides. So on this side, that will give us a negative 9,000 is equal to a negative 2,000x. So I'm going to write this over here. Divide each side by negative 2,000. And then that would give us negative divided by a negative is positive. This will give us 4.5 is equal to x. So we could say it takes 4.5 years for the car to be worth $6,000. All right, now it says give a description of how to find the slope of a line and why it represents a rate of change. I'm going to start off with why it represents a rate of change. It represents a rate of change because slope is a fraction, because slope is a fraction. And then I'll put the fraction here is rise over run. That's the fraction. Okay, now it says give a description on how to find slope. So to find slope, we divide the change in y over the change in x. Okay, now it says give a description of how to find the y-intercept of a graph and the x-intercept as well. Include a definition in your own words of what the y and x-intercepts of a graph are. So first, let's do that. The y-intercept is where the graph hits the y-axis. The x-intercept is where the graph hits the x-axis. And that's it. Well, it says include a definition in your own words of what the y and it's, yeah, we already did that. So that's basically it for this section. And if you have any questions, feel free to email me. Thank you.